Starting with a fresh scene, we created a noisy volume, which was, with a little bit more work, we could have manipulated it enough to create a cloud. But Houdini 13 has now given us some tools to create clouds pretty quickly, and they're great tools to use to create clouds. What we need to do is let's create a sphere. And this will define the region of our cloud. Now, if we create a cloud, stop and plug our sphere in for our display flag, it doesn't look like a cloud right off the bat. It looks like a sphere, which we've all seen. They have uniform sampling at 50. We could do it by size if we wanted to. We've kind of already covered this type of stuff. But it basically is just taking the geometry and converting it to a volume. But you do have some options, such as the flatten to... wrong one. To flatten the cloud. Because typically clouds are kind of flatter on the bottom. But again, it just doesn't look like a cloud. So we do have another node called Cloud Noise. Now this is all very flat looking, as you can see. An important thing when you're doing any kind of volume modeling or wanting to look at fluid sims, pyro sims, whatever, it's always good to have a light, because Houdini's viewport does a really good job of shading the volume in the OpenGL viewport. So I'm just going to kind of zoom out here, hold my control key, and click on Spotlight. And now we start to get some shading. Let's go back in. We can increase the resolution, volume. Now on our cloud noise, we've got a variety of parameters. Element size, which is our frequencies. So you turn it up, you're going to have bigger, kind of more bulbous shapes. We'll kind of turn it there. You have amplitude. I turn it to one that may have... If we turn our amplitude up to, say, 0.35, let it cook. Okay, we start getting kind of more interesting shapes. The other thing we can do is if we want to, let's turn this to a polygon, 25, get some resolution. If you wanted to start with kind of modeling your cloud this way, we want a really tall cloud, something like that. You know, this will be our base cloud shape. I'm going to turn this a little bit coarser just to get faster feedback results. As I'm recording, my RAM and processing power takes a hit. Okay, so we have a cloud here. You can manipulate it a bit more, like if we want to flatten. Now you can dive into either one of these. You can see that it's blue letters, which means this is a digital asset. You can jump in and actually see what is being done to create this shape. So it's bringing the volume in. And then here, it's using a volume VOP. And you can go inside here and see what it's doing. Now, this looks a lot more intimidating than what it really is. They've provided various switches for if you wanted to apply certain noises and such. All these yellow parameters are just the parameters which are promoted up top. But really, it's just you've got some noise. This is a noise as well. But this is doing an iterative noise using a for loop. You can go in and really see the guts of it. But the root of it is it's doing some noise And then basically what we did in the previous video is it's modifying the sample position of the volume. It's adding all this noise stuff to P, to position, and feeding it into the sample position. And then that's modifying the density. Well, we've got our cloud, but we don't necessarily need this to be a cloud. We can actually convert VDB, because we can see that it is a VDB volume. Plug this in the left input. And convert to polygon. Then we set it to polygon, and well, that's not very exciting. If I middle mouse, we have no points. What we need to do is we have a VDB fog volume. If we hover over this ISO value, it says the crossing point of VDB values that is considered the surface. 0 works for sign distance fields. 0.5 is a better choice for fog VDBs. Well, we have a fog VDB. So if we turn that up, we start to get something. Okay, so let's do what they say and just set it to 0.5. And now you can see that we have turned our cloud into actual geometry made of polygons and such. And this is, we can create kind of organic, nice looking lumpy rocks with it. But we don't really want to have these little pieces and stuff out there, so I'm just going to kind of tone down the amplitude a bit on the noise, on our cloud noise. So this is kind of a nice looking rock.